This is Lab 2, Lines of Charge. The purpose of this lab is to better understand charges and their interactions with everyday objects and determine excess charge left on a charged piece of tape. When tapes are treated as a line charge, the excess charge was calculated to be 2.33 times 10 to the negative 8 coulombs from the computational model. The physics in this lab were Coulomb's law, superposition principle, Newton's third law, Newton's second law, and that the electric field is equal to the electric force divided by charge. The assumptions in this lab were that air resistance is negligible, the tape is a line charge, not a singular point charge, as the tape is separate segments of point charges that are all equivalent and summed together. Each tape has an evenly distributed charge that are equivalent to each other. The data in this lab, which comes from the previous lab, was that the U-tape and my hand were attracted to each other, the U-tapes repelled each other, the U-tape and a random object, which was a book, were attracted to each other, and the U-tape and a negatively charged pen were attracted to each other, giving us that the U-tape is positively charged. The data in this lab, which once again comes from the previous lab, is that the length of the tape was 0.2 meters, width was 0.02 meters, the distance between the two flowing tapes was 0.03 meters, and that the mass of the tape was 0.0002 kilograms. The gravitational force, which is mass times gravity, is 1.96 times 10 to the negative 3 newtons. The electric force is the same value but negative, as it's negative mass times gravity. And that the big Q, the source charge, which is derived from the electric field equation, gives us 1.49 times 10 to the negative 8 coulombs. The number of electrons, charge of electron is being used, and the source charge, you have 9.33 times 10 to the 10 electrons. Atom length was 1 times 10 to the negative 10 meters. The atom area is length squared, so 1 times 10 to the negative 20 meters squared. And the tape area is length times width, so it's 4 times 10 to the negative 3 meters squared. The number of atoms is tape area divided by atom length, so 4 times 10 to the 17 atoms. And the electrons per atom are the number of electrons divided by the number of atoms, giving us 2.33 times 10 to the negative 8 electrons. Here is the code that is attached in my Glow script, which I show just the basic data that are put in, the electric field calculations, the calculations for Q, line charge, as well as the electric force and gravitational force and their magnitudes. This is what that code comes out to produce. The charge of one tape is 2.33 times 10 to the negative 8. The magnitude of the electric force is 1.96 times 10 to the negative third. The magnitude of the gravitational force, 1.96 times 10 to the negative third. Originally, the electric force did not equal the gravitational force when we were assuming that the tape was a point charge, so the guess and check method was used, assuming line charges, to reach a sum of 0 of the electric force and the gravitational force. You can see here in the code where it describes how each arrow was derived, and the link, like I said, will be in the YouTube description. The questions in this lab were, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So using a point charge, we have 1.49 times 10 to the negative 8 coulombs. Using line of charge, 2.33 times 10 to the negative 8 coulombs. So there's about a 50% difference between the two of them. So to continue on that, why do these estimates differ? Which value is more likely to be closer to the real value, and why? The point charge model treats the tape as a singular charge, but the line charge model treats the tape as multiple charges across the tape, so that's why we have different numbers and that 50% difference. And the line charge model is actually going to be more accurate because it more represents what tape is like in real life. It's not a singular charge like a point charge, it's made of multiple charges summed up like the line charge model. And that is all. Thank you.